Hello and welcome to a revisiting of Module 2. So I thought I'd take a step back, talk a little bit more about some of the neural network algorithms, and then walk through some of the examples that didn't work the last time I tried, and I figured out why. It was relatively simple. A namespace change in Cara, so we'll look at that. So the point of Module 2, as a reminder, is to understand the algorithms that are being used whenever we're dealing with training neural networks. In particular, things like how convolutional neural networks work, how you organize the structure of the network, be it the number of layers, the number of nodes in a layer, the type of layer, and things like activation functions and so on. So going back over what is a neural network one more time, you've got a series of nodes and a network that are connected together in some fashion. This is how we think about them in reality. It's more like matrix math, right? So we're doing a lot of matrix multiplication in there. That's where things like GPAs make a big difference whenever you're doing this stuff. So it's probably worth the trouble of getting that set up, depending upon how much of this you end up doing. And in fact, because of that, there are virtual machines and such inside of Azure that make it relatively easy to use GPUs for this type of work. So again, kind of revisiting, we have these neurons. We have the concept of adjusting the weight based upon the values that are coming in, and the error potentially that we've seen between what we were wanting and what we got. So it's a way of kind of trying to adjust to better fit the curve, is a kind of a way to think about it. And it's all about trying to get the output of the overall process, trying to get it to match something that we're training it on. The basic idea of, again, you can think of it simplistically as being similar to adjusting a line by adjusting the slope with the weight, applying that to some input value, which is x, and then you may want to shift it around through the use of a bias, so you can essentially move things up, around depending upon where you want it to be. When we talk about convolutional neural networks, it's all about mostly about images and detecting things like layers and edges and objects inside of images. So we move things around, look at it from almost like a three-dimensional perspective. So let's try this again. Didn't have to hit the control that time. So it should be opening this up somewhere. Let me go find a browser. Where did it open it? Okay, that's why, because I'm I thought I'd be clever and switch to Jupyter Labs, but so I'll go ahead and shift over to my Windows subsystem for Linux, and run Jupyter Notebook singular, and then hopefully this will work this time. Yeah, there we go. So the error that we saw last time, and I fixed it on some of these, but it must be that the namespace has changed more. Cara's has been moved underneath of TensorFlow. So if you encounter the error like what you see that we saw last time, it should be this easy to fix. So I know that I've got Cara's and TensorFlow installed. So which is it not liking? Normalization. So as always, it may actually still be in Cara's. Not what I did. So maybe it's not normalization, it's just layers. Yeah, there we go. so that's one of the things that they definitely they're moving things around on us, right? So um, can be challenging. So we can take a look. We see what versions of the various software we have installed: NumPy, Caras, and TensorFlow, um, and scikit-learn. So the first step here is to load the data. In this case, we're doing train happy and so on. So this is from hands-on neural networking with Caras, and the nice thing with Jupyter, it took me a little while to figure this out, but if you're in the current directory, your notebook is referencing data that is local to it. You can basically just read it. You don't have to do some of the things which I've done in the past of trying to come up with some sort of clever path and so on. Inside of the resources folder, and we're looking at hands-on neural network with Caras and chapter 4. So here is that folder, and so we've got these H5 files out here. We're able to load it, and then essentially we're coming up with what we normally do. You're splitting your data into test and train, so we'll go ahead and load. So this is just setting up the function that we actually call down here, and you're returning back a tuple of 4 things, which I've got to say is one of the coolest things about of Python, is to being able to have multiple things coming back without having to do anything artificial. If you were to do this in some other language like C#, you'd probably have to introduce a structure, or you might do something hackish like do them as out parameters, or return a structure, as I mentioned, or an array. But this is really nice from this perspective, because it lets us just kind of jump right into it. So we can take a look and see we've got the image dimensions are 64 by 64 by 3, and we basically have a training tensor that's going to run through here, and so on. So we can plot out one of the images to see what it looks like, and see it is roughly 60 by 60, and color. So the follow 3 would be RGB values. So the next thing we do is kind of all similar to what we do on some of these other things, which is basically normalize things. It's making things fit into a certain space, and potentially reducing the dimensionality in the process. So we can go through and plot an image that should be labeled as I guess a smile. That's kind of a smile. And so the next step is to go through and set up our sequential model, which basically just means that we're going to have a pipeline series of things that we want to do. And we start off by adding the convolutional 2D. This looks familiar, right? And then we do a batch normalization. Then we do a max pooling. Then some adding a dropout. Again, convolutional. Again, some normalization. And then move into another pooling layer. And then another dropout. And then we flatten it out. So that we can then apply our ReLU, which I looked up. I've used it before. It's a rectifier, so it's a curve, and it's amazing how good Google has gotten of giving you a nice little summary. But it's basically a curve of that shape. So it is the blue line that is essentially behaving in that sort of pattern. So it's just another sort of activation function, right? And then on the final layer, we actually switch it over to a sigmoid. Pretty easy to read, and understand that not all code that you'll run into that somebody's written, even within Keras or TensorFlow, may not be quite this well written, but it is a good pattern to get into to follow that sort of approach. Next thing is to go through and actually compile the model so that we can then run it We do a summary to kind of get a look of what is it that it is going to do, and this is what's going to occur during the entire one epoch, right? Basically, we're gonna do all that stuff to the training data one time. Then we're adding this ability to stop early with a callback. So a callback's kind of like the concept is like a delegate or a pointer function. So the idea is that if some event occurs, then you have a mechanism of letting something know, right? So in this case, we're saying if we reach a place where it looks like there's too much loss of value, then we stop. So the next thing is the actual training, where we're doing the actual passing all of the data through 20 times, and it did it pretty quickly. And then now we do a prediction. So this is always fun. And this is a challenge you have. Things they evolve over time. And so it's look like it's only available for the sequential class, the first class in your model. So it looks like it might have sequential class. Looks like that should have worked to me. Let's see if it probably can't do this because we can't do the actual predict. Don't suppose that. No. I was hoping that IntelliSense would give me a hint. So model is of type sequential. We create it here. That's not exactly the error that we're looking for. TensorFlow, Cara's normalization. It's this dot layers is the problem. So I'll read that error one more time because I thought it was complaining. So it's sequential. So that was what it was complaining about. So I think maybe it's there's an advantage of pinning your version number of your various frameworks to something to where you don't have this challenge, rather than spending a bunch of time on this, we'll go ahead and shift to the ones I know I've got working. So we'll go to this because this is a pretty good sort of simpler solution than the smile detection is. So here, this is kind of in the hello world of neural networks, right? A very simple sort of thing. We're doing a sequential, again, a sequential model. We're adding, then we're doing a summary, and I'm cheating to see if they happen to do a predict here so I can figure out what's wrong with that other one. Model.predict. So it does the same thing, and I know this one works. Exact same thing. So I'll take just a moment longer on this, and then we'll move on. So I'll come back to that if there's some time. So what we're doing here is training on squaring again. So the input of x is 1, 2, 3, 4. What we're trying to predict is 2, 4, 6, and 8. So basically just actually not even square or multiplying by 2 is what we're doing. So the process is very similar. We start by importing sequential indents, and then also a deep copy. We'll see that in a minute. And basically all that does is take something that has a collection and make sure that you make a true copy of it rather than just a referential copy. So we set up our arrays of both the training or both the input and the output of what we're trying to do. We set up a dense layer with 3 nodes using the ReLU activation, and then we have a linear activation on the next layer. So this is a really simple sort of thing. Only has about 2 layers in there, it looks like. So if we take a look at the output of the summary of the model, it is sequential. There's a dense layer that takes in basically 3, and then another dense layer, and then so we get our output from it, basically is what it comes down to. So the next step is always to do the compilation. So we're actually creating it, and then they go ahead and show us what the weights look like before we do any kind of training or anything. Then they're actually here showing the feed forward and then the update weights function, right? So we're defining essentially the dot notation. So you're multiplying the inputs times the weights plus the weight, right? So the pre-hidden, hidden, and out, and then they're showing the squared error. The same thing for the feed forward. So it's basically showing you what the pre-hidden, the hidden, and the out is, so that you can see it. Or I'm sorry, and the update weights. So you're seeing the inputs, the outputs, and the weights, and the epoch that you're working through. So then we then essentially run through all the epochs, doing our training. So we're basically showing it at a more in-depth layer, and then actually calling model.fit and then get the weights. And what we're demonstrating here is that the 2 outputs are the same, and then do a prediction and see how close we got, and then talk about some calculating the cross entropy for the categories, and you can see the overall result. So the only thing that I really had to change on this to get it working was adding the TensorFlow in front because of the namespace change. And then moving to, let's go ahead and save and then close that. another example. I'm sorry, another example. This is actually a little more, I guess interesting is a good word. So it's probably not the best practice, but I typically do the pip install inside of my notebooks just to make sure it's working. So we start off by importing NumPy and TensorFlow, sequential and dense, the sequential model in the dense layer. So what is the difference here? Actually, I'm showing you the simpler one. So this is going to be a sequential with one layer, right? So there's not much to this network. We take a look at the weights, and then do some optimizing, do the compile, get a warning that's telling us something is deprecated. The LR looks like. So again, we import copy from copy, deep copy, so that we can actually make a copy of the weights, because this model.getWeights is going to return something that's essentially a reference, and we want to persist it longer than that. So we can take a look at what those weights look like, and then we're pulling out the weights, a particular weight it looks like. Or we're setting the weights to that is what we're doing. And then taking a look at the first value. Again, the feed forward and the update weights function. And again, you don't really need to do this as we've seen on other ones. This is just so we can walk through it. Making a copy, running through essentially the iterating over the range, and then plotting the weight differences over the epochs, and looks like the initial weight started at 1.5. And then plotting a similar graph when the initial weight is 0.01. You can see they're very similar. Getting a copy of the weights and making essentially a copy of them and putting it into a list so that we can see them, and then doing the actual training using the model itself, getting the weights, and then we're into my code where I was trying to see if my GPU was working, and spoiler, it's not, so I need to look into that. So that's pretty much those two notebooks. So the key concept here is, first of all, Stack Overflow is your friend, as is the Wikipedia sometimes, even though it's not a scholarly source. So moving into deliverable 2, which is around this observational data training. As we discussed last time, you're tasked with of creating some training materials so that you can instruct your staff on how to do training. So a bit of a circular sort of thing, but the basic idea is that you need to know how to do training properly so that you can, for your tasks, your company can do it well. So the thing that you're asked to do is assess the typical results of each step in a neural network and list each one, describe the nature of training and test data sets, and then explain what is a convolutional neural network. Provide, basically you're going to submit Word and PowerPoint presentations. So the basic idea is you create the Word document first and then harvest from it to summarize to do your PowerPoints. That's probably what I would do. The criteria, there's 3 of them. A thorough and detailed discussion has been developed that contains an assessment, the typical results, that includes the typical results of each step in a neural network. That's a typo that wasn't from me. A thorough and detailed discussion has been developed and describes the nature of training and test sets, and that's basically that second bullet point, and then a thorough and detailed explanation has been developed of the convolutional neural networks. Hello, John. Still no audio. Good times. So basically all I did today was kind of revisit Module 2, since that's where you're at. The key thing on that I figured out, at least partly figured out, was some of the examples you'll see are a little older, and so they have a namespace problem. So they renamed the Cara's stuff to be underneath of TensorFlow. So it's TensorFlow.Caras now, not just Cara's as a top-level namespace. So if you happen to be poking around in either the resources that are available inside of O'Reilly or whatever, be prepared for it maybe to be old and not quite work. And these things aren't old books. I mean, that's the part that's interesting, as I purposely try to stay in newer versions. There's ways around it. You could basically pin the version of Keras or something. So whenever you do your pip install, say equals whatever version it is that you want to use. I personally don't like using old stuff, so I usually go through and fix it if I can. But the pattern pretty much is what we talked about. You create a model object, typically sequential, then you add some layers to it, specifying the number of nodes and the activation function, right? And then you essentially call fit on it eventually. So that's pretty much what I went over. I know you can't, your audio is not quite working. Any questions or concerns? Feel free to type it in the chat if you have any. So in a nutshell, what is a convolutional neural network? Yeah, no biggie, right? So the short answer is it's an approach of what it enables is that it enables us to go deep on the number of layers, right? So that's the point of it. The way it does that is by essentially doing that multiple windows sort of approach, so that you look at stuff essentially from different positions with the intent of getting what the context looks like, right? Back to our little robot friend. If you think about what you're doing to the data, and that may help, you essentially, if you're dealing with an image, you essentially turn it into a vector. That's kind of how they work at the end of the day. And what that means is that the location of a given, say, pixel, which is where this stuff is typically being applied, becomes lost if you do that, right? So you can't necessarily tell that if you're doing handwriting recognition and it's an 8 or a 9 or whatever, it's kind of hard to tell that because you just got a pixel, right? So that I think is what, at the end of it all, why it really kind of works, is that you're basically getting lots of different views onto the same information, so that you're diminishing that impact of having to essentially serialize it out to a single string, right, or a single array. And it is that's probably as good of definition as I've ever heard, right, as to kind of how it works. You'll see some things where they kind of show it at a three-dimensional perspective. It's kind of what you're doing, but you're more doing it on this, like you see on the screen here. You're taking it and resampling and subsampling over and over again, and the whole point of that is things that are relative to you are important, right? So especially if you're trying to find something like an edge, we tried to do it way back when with 3 layers neural networks, and it didn't go real well because again, it's it's this, how do you know that it's the width of the picture down, right? So you've got to know that you need to add the, whatever it is, if it's a 60 by 60, you need to add 60 to the, to know what's right below you, right? So um, hopefully that kind of helps explain it somewhat. But it is all about that whole subsampling, and I think that's the reason it's magic. So yeah, the uh, and probably the and our learning is a continually evolving thing. So the point of this assignment, and the reason I think it's actually a pretty good one, is in order for you to explain it, especially if I take away jargon. So if I tell you you have to explain it to me and you can't use any kind of jargon, technical terms, or anything else, to do that, you've got to have a really pretty good understanding of what it is, right? So that I think it's actually a pretty good assignment. Um, the duplicate of a PowerPoint and a Word, I kind of get the point. It's trying to make sure you really get it, right? Um, and it shouldn't be. There's no page requirement there, right? So just make sure you cover the topic, cover those 3 points, and we'll be good. I need to find an animated CNN simulation. That'd be cool. I wonder if there is such a thing. Because that actually might show it better. I don't like I can spell. Yes. Google will figure it out. Oops. That's what I actually wanted. Yeah, probably not. Yeah, you'd have to. Sometimes you can find cool things, but probably not here. Yeah. It's not terribly useful. But anyway, so I'll see if I can find something cool that shows it in a better way. This might. Draw my number here. Okay. How hard can this be? All right. So, okay, we hide and show layers. So that actually is pretty cool. Yeah, definitely. So your downsampling layer is about, again, that's that kind of shrinking it, right? And this is actually a pretty cool tool. 8 is always hard. Yeah. And is it 6? Maybe it's 6. There's one of them. Oh, there's this pretty good. So, because it's showing you here what it is you picked, right? So that's the output. Oh, hey, so we hover over things. Oh, no, that is cool. That is really cool. All right, that goes in the chat window. It's always hit or miss when you do things live, but yeah, that one actually works pretty cool. And it's somebody's project, it looks like. So that's actually pretty good. And it also gives a first and second guess over here as well. That's really cool. Because yeah, very cool. And second guess is 3. I'm not sure why that would be, but anyway. So I've played long enough. Any other questions? Were you pretty good? It looks like your video is spinning. All right. All right. Well, thanks for joining. I'll give it some more thought, and maybe I can add more color if you still need some kind of description on kind of why it magically works. Again, thanks for joining. Always appreciate it whenever you stop by. Stay safe, and we'll talk again soon.